So I came across Table D16 in the Canadian Electrical Code, and I haven't seen this one before, so it had me pretty confused. So what do we have here? Sizes of conductors, fuse ratings, circuit breaker settings for motor overload protection and motor circuit overcurrent protection. So first thing to me, that's Table 29, which they actually have referenced here, Table 29. So why do we have another table for this? So let's look into this. We have rule reference 200 here. And the key phrase that we're looking at is for overcurrent is right here. So I'm not seeing D16 anywhere in here. Referencing Table 29. And what does it say? That the overcurrent rating shall not exceed Table 29. Table 29. Let's use a induction motor. Your standard induction motor is squirrel cage, full voltage. So the overcurrent protection for a motor branch circuit shall not exceed 175% for time delay, 300% for non-time delay, and 250 for inverse time. And that's based on 28200. So why do we have a Table D16 not referenced anywhere in here? So let's go back to D16 and see how the numbers compare. Overcurrent protection maximum allowable rating. So we have our full load current on the left, and we have quite a few pages here. It goes up to 500 amps. Minimum allowable opacity of the conductor. So this looks to be 125% throughout, which makes sense. Single phase all types, and squirrel cage and synchronous full voltage resistor and reactor starting. So that's the one we want there. Squirrel cage, full voltage. This is your standard 3-phase induction motor. So let's use a 10 amp as comparison here. For 10 amp motor, 3-phase induction, the maximum non-time delay fuse is 30 amps. 15 for time delay and 25 for circuit breaker. So that looks like 300%, 150%, and 250%. Let's go back to Table 29. 300, 175, and 250. Now, why would that be? 175. Time delay is 175. So for a 10 amp, if we take 10 times it by 175%, that gives us 17.5. There's no standard rating at 17.5. Therefore, we're 15 amps time delay. So I'm starting to clue in here that this Table D16 is a cheat sheet for doing the calculations. Cheat sheet, lookup table, whatever you want to call it. I'm thinking here that Table 29 gives you the percentages required, and Table D16 does the math for you, which is kind of nice when you're in the field. In researching this, I actually came across this Reddit post, and this person actually had the same sort of confusion. Why do we have Table 29, 44 in D16? So they say, so I have a 50 horsepower, 600 volt motor. Per Table 44, the FLA is 52. So they're looking it up using the horsepower to FLA conversion table there, which tells them that it's 52 amps, their motor. Table D16 is based on 29. Yes, correct. What am I doing wrong here? And then we have, since you can't exceed Table 29, you actually have to go down to the next setting. So that's why we saw on table 16 here, same thing with the 10 amp example, 10 amps times 175 for a time delay fuse. The lower standard rating is 15. And one point to point out here, you're misreading table D16. I actually did this as well. They say it is a single phase, all types, and squirrel cage motor. So the next column is just for auto transformer start delta. So talking here, it is separated like this. So all types of single phase and squirrel cage and synchronous motors. Where this one is auto transformer and start delta, squirrel cage and synchronous motors. So we want to be, for your standard and 3-phase induction motor, we are in this column. All right, so in summary, for selecting an overcurrent device for a motor, we're looking at 28200 subrule 3, which says do not exceed table 29. Table 29 gives us percentages based on time delay, non-time delay, or circuit breaker. And table D16 does the math for us. Now, if you don't want to worry about all these calculations, you can always go to powerdesignerpro.com and have it automate the electrical design for you. Check it out.